Hello, my name is John Anderson, and today I'll be demonstrating to you my smart knowledge base about navigation within the UK. So if we take a look at the top of the screen, we'll see the first predicate that is involved within the system, and that's city. Now what city holds is the city names of the cities held within the system, so a lot of cities. So we have Newcastle, Leeds, Bradford, Manchester, Liverpool, Hull, Sheffield, Derby, Nottingham, Leicester, Birmingham, London, and so on. Now, this is good to have because it just separates all the cities from the rest of the data held. And it also allows me to make a quick and easy rule like this, where if we just consult the code and we type in show cities, what it does is it will just print out all of the city names held within the the knowledge base, which is it's good to have because let's say you're new to the system or you've just downloaded the app and on your phone and you just want to see what cities are involved within the system. Well, you can use this command and it will easily tell you, so let's say you live in Hull and you want to go to London, but you can just use this rule to quickly check to see if they're in, which is good to have. Now, the next part is the actual road network or the road graph. Now, we have here road. Now, in Prolog, this would be edge, but I thought, let's change that name to make it more about, navigation or about, about the roads, because we're doing about navigation on roads. So instead of edge, let's call it road to make it more understandable for someone who's not known about Prolog. They can say, here's roads. This must be about roads, about the information about roads. So each road has, we have the starting city or the city the road starts at, in theory. We have the end city or the city it ends up at, the end of the road in and then we have the distance. Now the distance in the system is in miles. And that's because, within the UK, that's what you use for, road miles in or the road measurement. And this data is true to life. So if you took a tape measure and you went from Newcastle to Leeds, it'll be a very long tape measure, but it'll also be the same as this rounded up. Because, let's say you make it the same system, but you have, instead of 102, you have 10. And if someone uses the system in real life and they have 20 miles of fuel in their car and they think it's 10 miles, they'll think, I can make this journey. When they actually do the journey, they will find out that that's not the correct method or not the correct data. So anyway, this road node also has a show roads, which is it just displays again all the roads connected within the knowledge base. If I just do this quickly to show you. As you can see here, it just connects it just shows all the roads and how far they are away to the user. Just again, it's just another ease of access command. Now, the first rule we have within the system is called connected. Now, what connected does is it just checks to see if two cities are connected together on the network. So, if we go to Prolog and we type in connected Newcastle Leeds 102, it'll be true because we look up here, we can see that this is true. Now, the good thing about this rule is if you look at the second part, you can see that the end city and start city is flipped. Now, what does that allow us to do? It basically makes us, if you take a look at this map of the network, instead of only going one way, it allows us to go both ways. So basically, we can travel around the entire graph, in theory, if you had enough fuel. So if we go back to connected, and we type in Leeds, Newcastle, it'll be out true, which is good to have. Now, this rule also checks for, you know, it'll say false if a city is entered and it's not known to the knowledge base. And it'll also check, so let's say you have the correct cities, but you have wrong fuel. It won't work because the knowledge base knows that this is incorrect. Now, the next part is the main pathfinding algorithm. So I'll just talk you through before I'll show you the output. So the first rule is like a validation. It's instead of an error or a false, it'll output this. Now, what it does is, let's say you are typing in your path, but instead of typing an entity, you type in the same city twice. So Leeds and Leeds with the same length with whatever fuel. So if I just do this quickly, so path, Leeds, length, and 10 fuel. It'll output 0 instead of false. Now this is better because, in my opinion, what this shows is, instead of false, it will tell the user, hey, you wrote in the same city twice, you haven't moved, length is 0, which is good to have. Now the next part is where we've actually write in two separate cities. So what it does is you write in your city you are at currently, the city you want to go to, and how much fuel you have. What it'll do is it'll check you have more than one fuel. Because if you have less than more than one fuel, you ain't going to go too far. And what it'll do now is it will check using recursion what city can go from the place you want to go to. Say you want to go to start Leeds, and you want to go to London, or Newcastle to London, or wherever. It will check to see, I want to go to here. Let's see if I can start at Bradford. Can I go from Bradford to London? And so on. It will just check to see which part can go from where. Can you make a path from a certain, so say if you start in Leeds, it will check to see with each one to see, can I get a path from Bradford to London, or Manchester to London, or so on. Now, each move it takes, it will deduct the fuel, your total fuel, from the total length, or from the length from each move you take. So if you start in Leeds and you want to check from Leeds to Bradford and you have 300 fuel, it will take away 15. So from 300, fuel 1 will be 285 instead of 300. Now, once you have made it, basically here it will continue to look until the next city. So once it's figured out that if so, what's this example? If Leeds goes to Manchester, if you go if you can go from Leeds to Manchester, and the path can follow. So if you go here, if you go from Leeds to Manchester, and you can work out a path from any way to London and back, it will then output saying, we can, and it will write it here into the console. And also, length this length here that when you type length in, it will output the total journey from start to end, which is good to have. Now, if you look closely here, this exclamation mark is called a cut in Prolog terms, and what that does, it prevents saying, can we find a different path? So what it does is, once you found the path, it will just show you only one path. It won't try and show you another path. It will just stop you here and stop, what's called backtracking, basically. So now I can show you. So if you go, sorry again. So if you go path, scroll down a bit. If you go path Newcastle, London, length, and let's say we have 330 fuel. As you can see, we went from Newcastle to Leeds, Leeds to Sheffield, Sheffield to Derby, Derby to Leicester, Leicester to London. So let's look at the graph again. We went from Newcastle to Leeds, Leeds to Sheffield, Sheffield to Leicester, Sheffield to Derby, Derby to Leicester, and Leicester to London, which is a complete path. Now, if you look at the bottom here, it'll tell you the total path. And there you have it. A path finding rule. So that brings me towards the end of this presentation. Hopefully you understand how the system works, and thank you for watching.